All right, I'm going to show you guys section 9.8, the power series. And what we're going to do in here is going to be, if you think about our 9196 test, they would give you a series and go, does it converge or diverge? What this is what values of x could we plug in to make it converge? Like, so is it possible to plug in a number to make that a convergent series? Which values would do it? So different tests that we could do to do this, to do interval, it's called interval convergence, or sometimes AP test will just ask radius convergence. I'm going to teach you a way to find them both every time. So that way you have one skill, you can always find the interval, you can always find the radius, no matter which one they ask you for, okay? We can either use a ratio, geometric series, or root test. Normally it's a ratio test. So ratio test is actually our most prominent one that we'll use. The geometric series test is a little faster if you can do it. So for example, I started you off with the geometric series one so you could see that. And again, I could do it by root test also. But I wouldn't choose root over geometric series, and we'll talk about why when it comes up here. So what you do is, the geometric series is, this looks like a geometric series if this is a ratio to the nth power. Well, we learned that the absolute value of the ratio has to be less than 1. So to find the interval of convergence, that the absolute value of the ratio is x minus 2. The absolute value of that has to be less than 1. And we're just going to solve for x. That's it. So now you guys learned in how to solve absolute value inequalities back in IM 1. And some people are good at it, some people are not good at it. So the little shortcut, I'll explain why, but here's how easy it's going to be. It's just going to, your thing is always going to be between -1 and 1. And the reason why is this was an and statement. When the absolute value was less than was an and statement. It means it's less than 1 and greater than -1. So less than 1 and greater than -1. So we'll write one statement like this every time. Now you add 2. And that's your interval convergence. So what that means is if I plug in numbers between 1 and 3, this would be a convergent series. All right. If I plug in 1, 3, it would not be a convergent series. And if I plug in anything on the outside, it will not be. All right. And that's your interval convergence. So my interval convergence, 1 to 3. Now, what would the radius and what's the center? The center would be right in the middle. Well, what's halfway between 1 and 3? 2 is the center. And the radius is the distance from the center out. So if the center is 2, how far is it from each end? 1. That's how easy it is to do the radius convergence. Now you can see whatever x is subtracting, we learned that from Taylor series, whatever x is subtracting, remember, was your center. So x minus 2, so you can see the center right off the bat. Okay? Now, let's find a number that fits in here. Let's try like 2 1/3. Well, if I plug in 2 1/3 minus 2, I get a third. Remember, 1/3 is a geometric series. It's less than 1, so therefore it's convergent. So what about 2? Well, 2 minus 2 is 0. Well, if you just add a bunch of zeros, that'll have a sum of 0. So let's see why 3 doesn't work. 3 minus 2 would be 1, and remember, the ratio has to be less than 1. Okay? So that's your interval convergence. Now that's the easiest one we have. It gets a little bit more complicated than some of these others. So what we need to do is we need to do the ratio test to find it. Now, here's how it works. So remember the absolute value. Now here's where the absolute value is going to be real important. I told you back when we did ratio test, the absolute value would get rid of that alternating series back in 9.1 and 9.6. So here we need it to actually finish our answer and solve it. So the next term, remember you find the n plus 1 term, divide ours or multiple reciprocal. Now, we're not trying to find is it convergent or divergence. We're saying we want to know when this would be convergent. Well, if you remember the ratio test, it converges when it's less than 1. So this will be also the limit less than 1. So if you cancel this out, what some people don't understand is you're doing the limit as n approaches infinity. So they tie, so x is your limit. So the absolute value of x is your limit, has to be less than 1. Which I already told you earlier from this other one. Absolute value less than 1 means less than 1 and greater than -1. All right. Now here's what's different though. We have to check those endpoints to see if they work or not. Now I kind of mentally checked the 3 and 1, but geometric series clearly tells us the ratio has to be less than 1. But do you guys remember what this test, the ratio test, we do the ratio test, I can't eliminate the endpoints. If you remember, it says in the ratio test, when you get 1 or -1, it's inconclusive. We don't know. So when you do the ratio test, you must check the endpoints. Okay, so here's how we do that. We need to check endpoints. So let's first off check the -1. So I would write, hey, I'm going to check -1. You don't need to write check endpoints. I'm just doing this one time. You just write, hey, I'm checking -1. So what you're going to do is replace your original series, put -1 in there. Well, you know that's convergent, right? Because it's an alternating series, the bottom's bigger, so you're like, oh, it's convergent. So if it works, then we include it in our interval, so that point actually works. If we check +1, 1 to the n is just 1, so I get 1 over n, and that's a divergent series by p series, so it doesn't work. So then my interval is just from -1 to 1, including that. So you see how if we check the endpoint, if it works, we got to keep it, okay? This one, if you wanted to check on here, you could, but you would always get, divergent series. So geometric series already tells you the endpoints don't work, so I don't have to check them. So it's a nice little thing to do. All right, the center is 0. Clearly that's what x is subtracting up there. And then the difference between 0 and 1 is just radius of 1. All right, so the center is the number right in the middle of your interval, or whatever x is subtracting, however you want to see it. And then the radius is the distance from the center to the outside. Okay? All right, I'm going to do 2 more. Let me erase this. That sounds terrible. All right, so let me see what I got. Wrote it down. All right. So I could do this one by, it's all to the n, so I could do this by a geometric or a root. It's got the -1, I could incorporate all that stuff. But let's do the root test, kind of test it out a little bit, all right? Just to do something different. So the root test is limit n approaches infinity of the nth root. Now we could put all this, it's going to be absolute value, so it's going to get rid of that. That's what's kind of nice. So absolute value. So we can just leave this as x plus 1 over 2 to the n, right? Because it's all to the n if possible. And the nth root will just get rid of that. So don't forget we have absolute value. And remember the root test is exactly the same we learned the ratio test. It has to be less than 1. So the absolute value of x plus 1 over 2 has to be less than 1. Because the nth roots just cancel and we're left with absolute value of x plus 1 over 2. All right, that was the root test. So now, remember it has to be less than 1 and greater than -1. Multiply by 2. I'm going to do that over here. All right, I'm multiplying everything by 2. And then I'm going to subtract. I'm solving for x, so I'm going to subtract 1. So we know that somewhere between -3 and 1 is the interval. but we got to check the endpoints because the root test again is also inconclusive there. So let's check -3. We'll do it over here. All right, so we're gonna check -3. So if I plug in -3 plus 1 to the n, that would be -2 to the n. So when I check that, all right, so I got -1 to the n times -2 to the n over 2 to the n. Now, this -2 to the n is really -1 to the n times 2 to the n. So this right here, I'll put it in red, is really -1 to the n and then a 2 to the n. So the 2 to the n's kind of cancel. We have -1 to the 2n, which is really 1, just because it's squared, -1 to the 2n. So really just diverges. I mean, there's no bottom. It's like the nth term test. It completely fails. And if we checked 1, the same thing would happen. Because we could have done this by geometric series where we wouldn't have to check the endpoints. But if I plugged in 1, I get 2 to the n over 2 to the n. And we would need to do that somewhere. Check 1, I just don't have a lot of room for it. All right, we would check 1 and then go, oh, that gives me 2. They cancel to be 1 again. It's divergent n-term test. So the endpoints don't work. The center halfway between those is a -1. See how it's x plus 1, the -1's your center. And then the radius of convergence is 2, because -1 is 2 away from both ends. All right. All right, this is one of my favorites. So this is a good problem. It's a good thing to see everything happening. All right, ratio test. All right, so you'll see a lot of canceling in here. So these guys kind of cancel to be just an x minus 8. The top has one more. The 15s, well, this n stays here. These 15s. And we know that this has to be less than 1. So we're working backwards. Instead of finding this, we're going, hey, when is this less than 1? So limit my n's tie. So that's my coefficients. So we can jump right to here. And multiply everything by 15. Add 8. So I'll just, there's my interval of convergence from -7 to 23. So I got to check my endpoints. Let me check my endpoints -7. So I'd say, hey, I'm going to check -7. That would give me -15 to the n. Well, -15 to the n would be that. So if I plug in -7 minus 8, -15 to the n, that'd be -1 to the n and 15 to the n. So I just wrote them both there, over n times 15 to the n. So those 15 n's cancel, but now I actually have -1 over n, and it's an alternating series, and the bottom's bigger, so it converges. So -7, that guy is a convergent, so he's a keeper. Let's check 23. He just gives me 15 to the n. So I just get my 1 over n, which is a p-series that fails because the gap's only 1, diverges. So again, -7 works, but 23 does not. So my radius convergent is how far the center is from those. Remember the center, x is subtracting 8. 8's halfway between all those. And how far is 8 from both of those? 15. All right. So that's how you do interval convergence. You can also do radius, and you can also find the center. Okay. All right, I have two special cases, which I will do in the next video. I'll just show you a couple special cases. Okay.